Good morning, class. Our topic this morning is going to be on elastic properties of solids. Now, what can I remind you all we did last time? Okay? Yes, motion. Now, what is motion? Motion is a change of position of your body with time. And we have four types of motion. What are they? Random motion, oscillatory motion, rotational motion, and translational motion. Now from there we go to elastic properties of solids. Now what is elasticity all about? The elasticity is the ability of a material to regain its original shape and size after the distorting force is removed. That means an elastic material is any material that can regain its original shape and size after the distorting force is removed. Now who can give me a very good example of an elastic material? Okay, a rubber band. Yes, a rubber band is a very good example of an elastic material because when it's being stretched, actually it will stretch, yes, and then when it's released, it goes back to its original shape. Now from that where Hooke's law comes about. Now Hooke's law is actually a law that governs the relationship between the stretching force and the extension E produced in the material. I'll also go to look at Young modulus of elasticity, which involves stress and strain. That means at the end of this lesson, we should be able to explain elastic properties of solids, state Hooke's law, know the terms stress, strain, elastic limit, and Young modulus of elasticity. Now, what is Hooke's law all about? Now, Hooke's law says that provided the elastic limit of an elastic material is not exceeded, that the extension E is directly proportional to the load or the applied force F. The extension is directly proportional to the load or the applied force F. That means the graph of extension against load will be a straight line graph that passes through the origin. The same extension is directly proportional to the load, which verifies Hooke's law. On the other hand, if the load is continually increased, that the material cannot return back to its original shape, it means that we now have a straight line OP and a curve PEYB. Now, along OP is a straight line, which means that extension is directly proportional to the load. But a little above P is the elastic limit. The material can still return back to its original shape. Yes. But beyond E is the yield point. Why? Now at this point, the material has already, there's no elasticity at all. The material loses its elasticity. Now that means that the material cannot return back to its original shape. It has become plastic, and further extension can cause the material to either snap or break completely. At this point, it's called the breaking point B. That means B is the positional limit, E is the elastic limit, Y is the yield point, OE is the elastic region, and EB is the static region. YB is the breaking point. Now, according to Hooke's law, the stretching force is directly proportional to the extension or compression. It means that F is directly proportional to E. Now the force will be equal to K times the extension, where K is the elastic constant. So it means that K will be equal to the force over extension. Now we know that force. Now what's the SI unit of force here, class? Okay, no problem. Now what of extension? Yes, okay, meter. So it means that the SI unit of force is Newton and the SI unit of extension is meter. So the unit of elastic constant will be Newton per meter. So elastic constant is the force required to give unit extension. Elastic constant is the force required to give unit extension. take a very simple problem that has to do with Hooke's law. Now listen very carefully. Now a force of 0.8 Newton stretches a spring by 2 centimeters. A force of 0.8 Newton stretches a spring by 2 centimeters. What is the elastic constant of the spring? Now from the question, what is the force? It's 0.8 Newton. And what is the extension? The extension is 2 centimeters. The centimeter is not an SI unit. It means we need to do what? Like change it to meters. Now how many centimeters makes a meter? 100 centimeters. So that means it will be 2 divided by 100, which will give us 0.02 meters. Okay, that means the elastic constant, which is equal to force over extension, will be equal to 0.8 Newton over 0.02 meters, which will now give us 14 Newton per meter. Means that the elastic constant of the spring will be 14 Newton per meter. I hope it's clear. Alright. Now from there we go to the modulus of elasticity. Now assuming a wire of length L and it has a cross-sectional area of A of, which is a meter square, and it has an extension E, which is also in what? Meter, and by a force F, which is in Newton. Now the ratio of the force to area is what we call stress or tensile stress. The ratio of force to area is called stress or tensile stress. That means stress is equal to force over extension. Stress is equal to force over extension. Now we know that force, the SI unit of force is Newton and the SI unit of area is meter square. It means that the unit of stress will be Newton per meter square. Now strain. Now strain is the ratio of extension to length. Strain is the ratio of extension to length. That means strain will be equal to extension over the length. Now what's the unit of extension? Meter. What of length? Meter also. Now since both of them have the same unit, it means that strain does not have any unit. Now strain is a measure of deformation. Why stress is distorting force. Stress describes the distorting force. Now strain is a measure of deformation, while stress describes the distorting force. It means that strain will be directly proportional to strain. Stress is directly proportional to strain. So that means your modulus of elasticity will be equal to stress over strain. Now what is stress class? Okay, force over area. What of strain? Extension over the length. These are your modulus of elasticity will be equal to force over area over the extension over the length. Since stress is equal to force over area and extension over the length. So stress is force over area, while strain is extension over length. So your modulus of elasticity will be equal to force over area over extension over the length. Yes. If you have questions, you can ask. Any questions so far? Alright. Now that will be all for today. I'll see you some other time. Thank you.